Hi everyone, audiences and judges. We're from Vietnam. As we all know, the COVID-19 pandemic has exhausted doctors globally, health are in need of medication and technology. And for that reason, we would like to talk about our product, which is the IoT syringe infusion pump. Our team has 5 members. I'm Han, and I will talk about the idea of this project. Nhật Minh will present the objectives and implementation process. Quyen will present the components. Thanh Vu will present the results and innovation, and lastly, Dong Hua will present the future improvements of this project. So, the IoT syringe infusion pump is a pumping device that is usually used based on the analgesics such as painkillers and antiemetics to prevent the medication in our blood from being either too high or too low. Thus, it also avoids the large consumption of tablets. Another function of this device is to deliver the medication to our body through at a certain time, and especially in the case where medication must be slowly inserted. This device overall helps lots of nurses and also to avoid the mistakes.
Hi, I'm Nhật Minh, and I'll talk about the objectives and implementation process for our device. Now, first and foremost, we must lay out a detailed list of qualities that our device should possess. First, it should be stable, compact, and energy efficient. Secondly, it should be able to minimize errors and maximize harm reduction. And most importantly, everything about this device should be conducted remotely, from starting to stopping infusion, modifying parameters per patient, to handling infusions at multiple hospitals. This way, the labor force will be reduced significantly, and doctors can still carry out infusions although they are not near the patients, which is extremely helpful when we consider the dangers of the COVID-19 virus. Now, in the second step, we'll draw a schematic and design the case. And after we have finished the second step, we'll move on to the third step, where we'll test the device on a breadboard and 3D print the case. In the fourth and also the final step, the device must be tested thoroughly before it goes into operation. We conduct various tests on all the functions of the device to ensure that it contains fewest errors possible and meets all the criteria aforementioned in step number 1. Now next, we'll talk about the components of our device.
Now we'll talk about the components of our product. Our product has 2 sensors, a 4x4 keypad and the temperature humidity sensor, the DHT22, both of which are connected to Arduino Uno, the central processing system of our product. The keypad is where the doctor enters a patient's ID and volume of medications to administer. Arduino Uno receives digital signal from the keypad and analog signals from the DHT22 and displays them onto 2 16x2 LCD screens. The first screen displays a patient's ID and the volume of medications to administer. The second screen displays the current temperature and humidity level. When a doctor enters a patient's ID, Arduino Uno would check if the ID exists on an online server with the help of the ESP8266 Wi-Fi module. Only if the ID exists can the doctor enter the amount of medications to administer. After that, Arduino Uno would order the NEMA 17 stepper motor to turn, pushing the movable part of the syringe. Here's how it happened. The motor rotational movement is converted into a translational movement through a system of worm gear, a nut, and a 3D printed piece. This piece will be attached to the movable part of the syringe. The rest of the syringe will be immobilized with other 3D printed pieces that are fixed onto a rail with screws and nuts. On paper, we've calculated that we need to turn the stepper motor 416 steps to deliver 1 milliliter of medications. Please note that every 200 steps is equal to 1 rotation of the motor. In real-life testing, however, we found out that we need to add around 10 more steps to deliver exactly 1 milliliter of medications. That's why we've settled with the number of 425 steps per milliliter. When a verified doctor enters his or her dosage in milliliter, Arduino Uno would multiply the number by 425, and the result is the number of steps that the stepper motor will be ordered to turn. Finally, when the medications have been injected Arduino Uno would upload the patient's medical profile, including their ID and the amount of medications they received, onto an online server with, of course, the ESP8266 Wi-Fi module. This server is where doctors will be able to access the patient's medical profiles in the form of beautifully visualized graphs and numbers. The server will also keep the log of all the use commands should data inspection ever become necessary.
Hi, my name is Tango. Today I will talk about the research and the innovation of our team product. In the end, our device fulfills the original requirement and still ensures compliance. During the process of making this product, we only focused on its accuracy and didn't really care about variety setting. But now, the power consumption ends up surprisingly low. The whole system works smoothly and the syringe dispenses the exactly amount of liquid through our money test. This is our team device. For innovation, our products are easy to operate interface so that the doctor can easily handle the infusion of patients from the long distance to ensure their safety to control or precise time of infusion. Furthermore, the monitoring and maintenance costs are reduced because the spare parts are cheap and easy to repair. The next will be Pakao to talk about future improvement.
So thanks for listening to my teammates' part. Now it's my part. My part focuses on future improvements for the device. I believe there's 4 ways to do it. One of them being optimizing the price of production. If we can produce more devices at a cheaper rate, we can make more of it so that it becomes more common on the market. Therefore, many people can buy it, including the hospital, which we want. We also believe that it's important for the user to be able to control the machine to their liking. So therefore, the most logical approach would be building an app for remote monitoring. Another change we can implement maybe is optimizing the size. Even though it looks small like this, we believe we can make it even smaller so that the hospital can store more of it and still be able to save space for other products if they ever want to store more. The last part being integrating syringes into one pump. If time ever comes and a lot of patients need help at once delivering medication to their veins, this change would really help because we can help many people at the same time with only one pump, and we would want to help out rather than trying to capitalize on this one syringe at the same time. So thanks a lot for listening to my part.